position vector. Let's say you have 2 points, okay, A and let's say there is another point O. So now this O is a point of reference. Now A and B are 2 points, O a point of reference which is fixed. Now if we form a triangle, so in triangle OAB, AB is equal to, so let's say AB is equal to OA plus OB. So OA plus OB. So here point A, right? If we just talk in terms of points A and B, it becomes difficult to do much manipulation. Whereas because we have a fixed point of reference, we can say OA is the position vector of A and OB is the position vector of B, both with respect to O. So let's see how this can be really helpful, the concept of position vector. So what we are going to do is we are going to look at point dividing the join of AB internally in the ratio m:n. Basically what this means is that we have a line, let's say AB. There is a point somewhere on this line AB, let's call it as P. Now this point P divides AB in the ratio of m:n. So we want to come out with some kind of a formula by which we can figure out something about P. So let O be a point of reference which is fixed. So let's say O. Now let's connect this position vector of A would be OA, more precisely of point A is equal to OA. Let's say in short it is A. Similarly of point B is equal to OB, which is in short let's say B, and of point P is equal to OP, which is let's say R. Now even by looking at the diagrammatic representation, we know that P divides the line segment AB internally in the ratio of m:n. Okay, now since we know that it divides it in the ratio of m:1, it means AP by PB is equal to m/n, which implies NAP is equal to MPB. Now either we will be looking only as A and B, or we will be looking at BA. So either in this direction or in the other direction. Now in either case, it will be in one direction. So since directions of AP and PB are same, we can write NAP is equal to MPB. Yes. So direction is same, only magnitudes are different. That anyhow N and M are taken care of. Okay. Now AP can be written as, okay, so here in this diagram we know this is A, this is B, and this is R. So now AP can be written as, so let's say AP is a vector. So AP can be written as R minus A. Similarly, PB can be written as B minus R. Okay. So N times R minus A is equal to M times B minus R. Now it's simple algebra. N A is equal to M B minus M R. Now N R minus M R. Remember, we want R is equal to. So M B plus N A. Now let's take R common. So N minus M is equal to M B plus N A. So now R would be equal to M B plus N A divided by N minus M. Now this would become plus when we bring MR to this side. This would become plus. So this will be plus. This will be plus. Okay. So the vector R, which is nothing but the position vector of P, is equal to MB plus NA by N plus N. N plus M. Now this is when the division is internal. Now if the point divides AB in the ratio of M is to N externally. So what this means is we have AB and there is a point external to AB, outside the line segment AB. But if you connect this, then P divides AB in the ratio of M is to N externally. From outside it divides in the ratio of M is to N. So again we would use a reference point, and this is how the, let's say this is P. Okay, this is how the diagram will look like. This would be A, this would be B, this would be R. If P divides AB externally, then what will happen? Then R would be equal to MB minus NA by M minus N. You can just follow the same steps as before, but because the position of P has changed, you will end up with this formula. Just try to do it. It will be a practice for you also. Now, if P is the midpoint, that means it is exactly in the middle of AB. In case of internal, naturally, the moment we say midpoint, it must be in the in between A and B. So, which means what? M is to N, since it divides it equally, it is 1 is to 1. So, what will happen? R would be is equal to 1 vector B plus 1 times vector A divided by 1 plus 1, which is equal to B plus A by 2, or much more appropriately A plus B by 2. And we know that this is correct. See, because of vectors, how simple it becomes. Let's look at another very interesting aspect. The centroid of a triangle ABC. Now remember, the moment I say centroid, this is high school geometry. So you should know what a centroid is and what are its properties. Right. So let's say I have a triangle. Here, let's say A, B, C and D. These are the points of interest. So AD is the median, which implies that D is the midpoint of BC. Yes. And here this is, let's say, G. Now G is the centroid of triangle ABC. Basically, what is centroid? If you draw the three medians from A, from B, from C, then the point at which they intersect each other is the centroid. And G divides AD in the ratio 2:1 internally. Okay, so these are the properties of the centroid that you should be aware of. But once you know that much, then we can find something about, or we can come out with a formula for this centroid. Now, let's look at position vectors. Now, every time you don't necessarily have to put that O in the diagram. Just remember, it's a fixed point somewhere, and you just have to look at a vector from that point of reference to the point which we are interested in. So, OA is the position vector of A, OB is of B, yes, OD is that of D, OG is that of G, and similarly OC of C. Now OD is equal to, we know, half of OB plus OC. Now what is OBOC? OBOC. OD is half. So clear? We can say A, B, C. These are position vectors. D, and let's say this is R. So that means this can be written as D is equal to half of B plus C. This is 1. If you look at the division ratio, we can say OG is equal to 2 times OD plus 1 times OA, because it is dividing it in the ratio of 2:1, divided by 2 plus 1. So OD is what? OD is, we have just seen that it is half of, so half of B plus C times 2, or 2 times half of B plus C, plus OA is what? OA is nothing but A. The whole thing divided by 3. This 2 and 2 gets cancelled, and we are left with A plus B plus C by 3. OG is R. So this is the vector R, or this is how you can arrive at the position vector of centroid. Again, because of vectors, it becomes very easy. I think that's enough for today. Bye for now.